talk. Let me get this going. Wait. How's that? Great. All right. So as Indira said, my name is Jean. I am part of the semantic machines team at Microsoft. Like she said, I have a background in linguistics. Semantic machines is, trying to, advance the dialogue technology that we have in current conversational assistance, and some of this is, requires knowledge of language and the different parts, syntax, semantics, etc. So we were acquired in 2018, and so I was just going to show you some of the technology that we are working on. All right, so let's see if this works. All right, so natural language is the universal interface. So what does this mean, right? What is the way that we interact with our computers now, right? We came up with keyboards early on. The original interface was punch cards, and then we went to keyboards, and we have mice that we can move around, and we can click on things on an interface, and with tablets we can use our fingers to touch and interact. And so natural language, obviously, not just with technology, but everywhere is an interface that we use. So we are trying to bring that to the virtual assistant space and to the computer space. So what are some of the things that we think about when we are trying to bring a more conversational experience to speech tech and to virtual assistants? Well, we know that conversation is a cooperative, mostly human-to-human activity. And in the linguistics community, we think about discourse with this guy named H.P. Grice. And he sort of established a framework for how we think about dialogue between people. And so he came up with what are these things called maxims. So, right, make your contribution in a conversation what is required at the stage at which it occurs, by the accepted purpose of directions of the talk exchange in which you are engaged. So there are four main maxims that he sort of came up with that we try to think about. One is the maxim of quantity, which is to be informative when we're having a conversation. There's the maxim of quality, which is to be truthful in what you're saying. There is the maxim of let's see, I forget what it's called, but being relevant is the maxim of, oh gosh, anyway, the maxim of manner is to be brief. And so those are the things that we're thinking about when trying to create an experience with a virtual assistant. And as you know, I'm sure if you've interacted with your phone, if you've interacted with an always listening device like Siri or Alexa or Apple HomePod, conversation with language tech is not yet natural, right? It requires planning what you're going to say, how you're going to pronounce things so that it understands you. So it's not quite at parity with a conversation that we would have with other people. And so one of our goals is that we want you to not have to think when you're talking to a virtual assistant. So in the AI part of this, what are the things that we're going to try to model in this space? So these are some of the things from the linguistics side, right? There's discourse, there's pragmatics, which is sort of the context around the conversation you're having. Co-reference, which is referring to an entity and then using a pronoun to talk about it. Context is more of the pragmatics. In natural conversation, you're interrupted. You might change your mind in what you're saying. So the speaker interrupts themselves. Another person you're talking to might interrupt you. Salience, again, that's sort of a contextual thing. What items that you've talked about earlier are still relevant? Language is ambiguous, and how do we disambiguate the meaning of what a person's saying? And then there's also items like intonation, whether you're making a statement or asking a question. Prosody, which is the meter or the sort of song-like qualities of what you say. Emphasis, which things of what you're saying are important and how you express that through voice, and how you contrast things. So these are some of the things that come up in conversation that we're trying to model with these new experiences. So like I said, I am a linguist. I will give a background to some of the tech that we are working on. I can't answer specific questions about it, but I can lead you to people who can if you have further questions. But right now, if you think about your Alexa or your Google Home, what the technology works with now are what we call intents and slots. So if you have something like turn on the lights, that is something that that is relevant to your home. So this might be a home automation thing. And so your virtual assistant has these different skills, right? So you might have a travel skill, you might have a location skill, you might have the home automation skills, shopping, movies, your calendar, etc. So when you say turn on the lights, right, and for each of these skills, a certain amount of intents and slots have been built up. And so here's the one, right? It's within home automation. There's turn on the lights. So it understands that one. Then what if you say set a timer for 5 minutes? Well, that also happens in your home, perhaps. It's another home automation intent, but it's in a different place. So if you want to say turn on the lights because you're cooking, and then you want to set a timer, it's two different intents and slots. So then maybe you want to ask your assistant, what time am I getting coffee with Megan? Well, that's a calendar question, and you might need to activate a different skill, which is under calendar, to say, what time am I getting coffee with Megan? So again, this is a very sort of siloed way of approaching each of these different questions, which each have a different intent. So, right, the answer is, okay, you're meeting with Megan at 12:30 p.m. But then you want to say, okay, well, how long will it take to get there? So again, that is, within the domain or the skill of, locations or your maps. So that's sort of the current view of how these utterances or these commands get handled. So our view is that you don't have to have the skills. You don't have to have individual skills, and you don't have to have individual intents and slots for this to happen. So with our program synthesis, we look at the conversation as a program. And so instead of having to reach into each of these things, we have each of those things come together, right? So you have a home automation question, you have a calendar question, you have a map question, and that can come together, and the system can, call your calendar and find out what time. You can call the map to pull up the address you're looking for, and then give you a response, right? So it sort of goes into the individual pieces, not because they're siloed, but because it can call out to the maps, call out to the home automation, call out to the calendar. And so that is sort of the main difference between the current approaches and what we're trying to do. So, how does this look? And I can post some links at the end, but basically our team has been working with the Cortana team, and this is being integrated into Outlook Mobile. It will be coming out soon, and I have some blog posts about it. But just to give you a sense, and a sense of what it looks like, and also another thing to think about is, each of those questions that were asked before were very simple, sort of one subject, one idea kind of utterances. And I'm sure if you've asked more complex things to your virtual assistants, that they don't understand you because it's like too much information, or too far apart. So I'll start with a simple example, which is it is one utterance, but it is asking a lot of different things. So here's an example of a complex one sentence utterance that this kind of system can handle. Okay, so what's the weather going to be like 3 hours after I meet with Breeze Manager next Tuesday? So there's a lot going on in that, right? So there's a question on what's the weather going to be? Who is Breeze Manager? When am I meeting with Breeze Manager? And at what time? And then find that time and tell me 3 hours later what the weather is going to be like. So there's a lot of requests in this one simple sentence. And like I showed, the system can pull the calendar, pull the weather, and make the calculation of time, and can give you a response that it will be partly cloudy with a temperature of 73 degrees in Kirkland on Tuesday at 11:30. So that's one example of a complex single sentence question that this system can handle. All right, so let's show another one. Oops, is this the same one? Yeah, hold on. All right, how about this one? Okay, so another thing with current virtual assistants is that holding the context of a conversation is becoming possible, but is not mainstream possible. So this one shows that when is my afternoon run, right? So it finds in the calendar the event called afternoon run. It tells you what time it is. It tells you where it is. And then it says, what's the weather going to be like then? So coming back to the ideas of context and salience, that on its own, what's the weather going to be like then is making reference to the sentence before, what we call turns in the conversation. So it's holding in its conversational memory that you've asked about an afternoon run, and the weather, asking about the weather, is related to this previous turn of the run. So, right, okay, your run's at 5 o'clock. It will be clear with a temperature of 85 from 5 to 5:30, because that's when your run is. Okay, and here's another example, I think. That's the same one. Okay, hold on. Let's try this one. So this is a more complex example. So when it started, it asked, what's on my day? So it could look through the whole calendar. And when it pulls up your calendar items, you can ask questions about the event itself, right? Where is it? Who's coming? Is so-and-so invited? And can you rename it? So these are all things within a context that requires the system to sort of keep some salient contextual events in its memory, in its plan, so that you can do things with it. And yeah, it's really neat, and I'm excited for it to come out and have people try it, because it's pretty powerful. So here's another one, I think, or is this the same one? No. Okay. I think this is the same one. There's time I can show it again. So yeah, that is a little bit about what we're doing. And like I said, I can post some of the blog posts in the chat about some more information about how this is going to look with the new Cortana experience in Outlook. And I'm happy to answer any questions.
Thank you, Jean.
After, sure, yeah.
Questions in the chat already. I think the first one I see is, what's the technology behind the speech to text?
The speech to text, so the speech recognition, I assume?
I am assuming so. I don't know. Lena,
Yeah.
if you're here, if you want to clarify, feel free. Yes,
speech recognition. So we are just using Microsoft's standard speech recognition system. We are working in the current iterations. We have a process for sort of catching utterances that are misrecognized for the domain, so that the system, because obviously that is right. That is the first input to the system, and it can't do the things I just showed you if it doesn't understand you correctly in the first place. So we are working to continually improve places where the speech recognition is not doing well on questions of this domain and for pronunciations and whatnot.
There's I think a really question on the speech recognition aspect from Miggy. Can it pick up accents? I always find that this type of technology can't understand my accent.
Yes, accents are a huge issue. And right, I mean, I guess, one thing to say is the system can only understand accents that it's been trained on. And for the most part, the training data that has been given to speech recognition comes from mainstream US English accents. So even if if your accent is from certain dialects in the US, or if it is a non-American English accent, it doesn't pick it up so well. And the speech teams work to get this input, and of course with privacy considerations, the audio that comes in is only held for so long, but we try to make the most of the data we do get, or for however long we can listen to it and keep it to try to improve such things. Yes, it's a valid point, because it is difficult for most people.
Shruti has a question. What have been the most challenging bugs to get through?
Let's see, gosh. Some of the challenging bugs have been with some of the contextual items, where you start to create something and you change your mind, right? And these are part of the conversational, even with a person, when you're trying to negotiate with them. You know, you start with one idea and then you go, oh wait, or you know, hold on a second, and trying to get the computer, or sorry, to get the system to roll back enough of what you mean, or you know, the system is hooked up to your contacts list, so you say, you know, have a meeting with Jason, and then it picks the wrong Jason, and then you're like, oh wait, no, and like hopefully it's not like the CEO of your company and it's, you know, doesn't send an invite to this person before you know, before you can stop it. So those things have been challenging. Also, just to get the speed of the system to a point where it's you know, usable to a wider audience.
Cool. Let's see. I see another question. Does the system harvest user reactions to feedback into the AI model to improve / fine-tune the responses?
Depends what you mean by the feedback. There are certainly ways for the user to give feedback. I mean, the conversation comes in briefly. Well, sorry, I should say in the dog-fooded systems that we have now, we are able to look at the user's utterances so that we can take their data and improve the models. The reactions can come through shakers, so you can shake it and send explicit feedback. So for example, you say, you know, I meant this, you know, the system didn't understand me when I said this, what I meant to say was this, or, you know, I can't get it to, you know, make this appointment or whatever. We do have those sort of feedback reactions, but in terms of, I guess, emotional reactions, not yet.
We now see many companies working on speech recognition. Are those shared across platforms like open source version, or are we still in silo modes?
That's a good question. At least for the purposes I know, it's I think within Microsoft there is one speech recognition system that we continuously try to improve. It's for different languages and also for different dialects of English. So there is a speech recognition model for Indian English, for example. There's a speech recognition model for British English. Microsoft speech recognition is available to the public through our cognitive services. I think it's slightly different than the one that we use for Cortana, for example, but it is available for people to try and use and you know, tweak the speech models for their domain or different purposes.
Cool. All right, last question. If I was interested in using this technology to build a toy app or a real app, is that possible at this moment?
Not at this moment, but we are definitely working on it. We're working on it so that other teams within Microsoft can build out different experiences with it, which you know, once that process is sort of is robust and our SDK is ready to like unleash, I believe that going forward that it would be more available to the public.
Awesome, looking forward to that.
Yeah.
And again, thank you so much, Jean, for the talk. I feel like, for me at least, I work primarily in front end, so this was very far from my own domain, and I feel like I learned a lot, so thank you.
Great, thanks.
Yeah, virtual claps. All right, so moving on to our next speaker of the night. Fiona Whittington is the co-founder and executive director of Tech Together, the nation's largest initiative to address the gender inequities in the hackathon community. Tech Together is credited with increasing the gender diversity of the hackathon community by 18% from 2019 to 2020. Her work for Tech Together has been featured in the New York Times, Washington Post, and Boston Globe. Fiona previously worked in marketing at Red Hat and Armored Things. In 2019, she received her bachelor's degree in advertising from Boston University. And without further ado, I'd love to welcome Fiona.
Awesome. Well, thanks so much for having me. Super excited to be here. I'm going to go ahead and share my screen so we can get started. All right. Can everyone see me and hear me? All right, awesome. I always give a ton of workshops for high schoolers, and they'll let me just go on for like 10 minutes without telling me that they can't see anything. And so I have to explain the concepts of GitHub twice, which for anyone who's done that, it's not fun. So today we're going to be talking about hackathons, a beginner's guide to hackathons, what the hell are hackathons, how you can participate in them, and why they're beneficial for your career. So as Indira said, my name is Fiona. I use the pronoun she, her, hers. I'm the executive director of Tech Together. I'm a graduate of Boston University, if there's any BU alum here, or just Boston people in general. And my background is in marketing and a wannabe software engineer. And so I want to talk a little bit first about what Tech Together is. So Tech Together is a national nonprofit organization that seeks to increase the gender diversity and inclusion of the hackathon community. And the reason that we focus on the hackathon community specifically is because we see it as a gateway into other professions. It's a really easy way to build your network, build your skills, and build your resume. So in general, again, we're just foster a safe environment for gender marginalized people to learn about different technologies, about different technology careers. And the main way we do that is by hosting these gender-focused hackathons across the country. This current hackathon season, we've served about 2,500 people of marginalized genders and have a community of over 10,000. So if you're interested in learning more about Tech Together, we actually have a hackathon this weekend that just kicked off. And you can subscribe to our newsletter. We also put other jobs, other things in the community, so you can subscribe there. So let's get started. I want to first start by polling everyone. You tell me, what do you think a hackathon is? Let me know in the chat. I'll just give us just a little bit of time, maybe 30 seconds to put in what you think a hackathon is in the chat. Getting together to learn and build something. Yes, where people can come together to code. That's a good one. And build together. UX, product dev, coming together to build and code. Yep, short period of time. Awesome. Well, those are the more more accurate descriptions of a hackathon I've heard. My favorite anecdote about hackathons is when I was first working with our incorporation lawyers, and our lawyer stopped me and said, "Fiona, are you teaching young women how to break into laptops? I just don't get it." And I was like, oh my God, let's sit down. Let me tell you what a hackathon is. I promise you it's not as malicious as it sounds. So I really have heard it all. They think, often I hear, what the heck is a hackathon? Are you breaking into things? Aren't hackathons just for coders? I want to attend, but I'm not a CS major, or I'm not good enough. There are so many stereotypes around hackathons. And again, Tech Together is all about breaking down those stereotypes so that more people can participate in the community. So when you Google hacker, the first thing you think of is, that white guy in a hoodie, which I'm sure all of you in the tech industry know that this is, a stereotype that we all encounter that we're gradually starting to take down, but it's something that is very rigid within the hackathon community. Mostly because the term hackathon, you immediately think hacker. But in reality, this is really what a hackathon looks like and what it's all about back when things were in person, at least. So what is a hackathon? A hackathon is a 24-hour to 36-hour competition where you come together with a team to build a solution that can either be software or a hardware project that addresses a challenge, and you enter that project to potentially win a prize. That's really the standard definition of what a hackathon is. And I always like to add in this picture because, again, this is what hackathons used to look like, but now that everything has shifted to virtual, this is at least what a Tech Together hackathon might look like. For example, this is what the hackathon this weekend looks like. It's just a bunch of people coming together over Zoom to build hackathon projects together and attend events. So I want to, again, start by debunking some stereotypes about what a hackathon is. So I saw a lot of people say, oh, it's about coming together and building things, but a hackathon doesn't always have to be like that. There are really two types of hackathon experiences you can give yourself. So the first one is exploration and learning. So this is really a good track if you are a first-time hacker, if you are ambivalent about building a project over a short period of time, maybe you have a full-time job, maybe you have kids, maybe you really don't have, all day to build a website. So in that case, you can just attend a hackathon to attend the workshops, activities, and networking events, and you don't have to build a project. It's basically like as if you were going to a conference, and I highly recommend doing so because hackathons have a very low barrier of entry for participating in them. They're often free, which means that you can connect with recruiters at companies like Microsoft, Capital One, Verizon. Those are some of the sponsors this weekend. Very, very easily and get yourself in front of them without even needing to, pay for a conference, worry if they're going to respond to you, et cetera. So it's a really low barrier way to build your skills, your network, and your resume. And the second one is the more traditional way that you all suggested, which is what I call like the experiential learning track, which is really just more of the traditional hackathon experience where you're attending workshops, activities, and networking events throughout. And you're building a project over the course of the weekend, either alone or with a team. And in the end, you're going to enter it to win a prize. And so I just want to quickly go through the pros and cons of each of these options. So for the first one, exploration and learning, again, you can totally attend a hackathon and make it all about learning. And again, the pro is if you don't build a project, you don't have the stress of building something over a short period of time. You don't have to worry about collaborating with anyone. You can just go to what workshops and activities that you want and not worry about anything else. But the cons are that you kind of miss out on like the magic of a hackathon, which is working together with people you either just met or you knew beforehand to build a project over the course of a weekend, which is fun because you're, you have a short time. And you kind of, again, are working with them very closely. And it's a really great way to build strong relationships with people you don't know over a short amount of time. And it's also good for your resume, obviously, to have the project. And then for the other one, for the pro, again, making those long-term connections with other hackers, potentially winning a prize, and then having the project to add to your resume. And then the cons is you do have less time to attend workshops and events. So for example, at Tech Together Hackathons, we typically have over 30 workshops that we host over the course of the weekend. And we always get complaints from people who are like, it's too many workshops. I'm doing too much. Well, we do it because we want to make sure that we have a workshop for everyone and you don't have to attend all of them. So again, it's good to, before you go into a hackathon, decide what you want to get out of it. And don't worry if that means not building a project. That doesn't mean that you are any less than anyone who is attending the hackathon to make a project. So let's go over the types of hackathons because there's a lot of different types. So there's collegiate hackathons, there's high school hackathons, there's company hackathons, there's gender-focused hackathons, which can mean a range. So if you identify as non-binary or trans, I recommend going for hackathons that use more inclusive language, but in general, a lot of them are female-centric. Tech Together's hackathons are for gender marginalized individuals. So if you want to connect with me to figure out which gender-focused hackathons are inclusive of the queer community, feel free to connect with me. And then there's industry-specific hackathons. So MIT Media Lab puts on a lot of industry-specific hackathons, which I recommend checking out if you're in Boston. And then there's technology-themed hackathons that are most always virtual. So IBM might put on a challenge and say, hey, if you use our X technology, then you can be entered to win X challenge. Or if you use X technology in your project, you can be entered to win our prize. So these are different types of hackathons. Again, I think most everyone here are industry professionals. And in that case, if you're a first-time hacker and you're an industry professional, I definitely recommend either checking out if your company has a hackathon or going to an industry-specific hackathon or a gender-focused hackathon like Tech Together, which doesn't have an age restriction on who can attend. So you kind of get the benefits of attending a collegiate type hackathon without having the barrier of actually having to be in college to participate. So just to, again, go over quickly what a traditional hackathon experience might look like, and I'm gonna break it down real quickly, some tips on each of these different steps. The first step is you register and you apply, you form a team, you come up with an idea, you attend workshops all throughout, you build a project, and you submit your project for prizes. And that's really it, and you do it within a really short amount of time, typically. And then the second experience is you just register, apply, you attend workshops, you network, and you meet new people. Again, there's no difference between these two that would impact whether or not you have a positive experience at the hackathon. They just provide different benefits. So let's talk quickly about the traditional hackathon experience, breaking down each of the different steps, what to expect for each, some tips. So for registering, applying, if you want to find some hackathons, the easiest way to find some are on the MLH website. I know that a lot of these are going to be collegiate, but if you want recommendations for non-collegiate hackathons, feel free to connect with me. I can give you some recommendations. There are also hackathons listed on DevPosts that you can look at that have a ton of options. And one thing to note is people often think that they need a team to apply and register. We get thousands and thousands of registrations each month, and I can promise you that 80% of the people who attend our hackathons don't come with a team. So if that's something you're worried about, just know that most everyone is attending alone and is there to find a team, so there's nothing to be scared of. And one of the biggest things that people are scared about when it comes to hackathons is forming a team. Because I don't know about you, but I find it really scary meeting new people. And again, it's, you're trying something new for the first time and you have to find these people virtually. It can be really overwhelming, but there are a lot of different ways to find a team at a hackathon. And I'm not going to go in depth because I know we only have 20 minutes, but there will be team formation events. There's, Slack and Discord channels that you can connect with people. There's usually hacker hangouts and team bonding activities. Some hackathons will facilitate team formation even before the hackathon begins, so you can fill out a form and they'll automate the team formation for you. Or you can reach out to groups like Women Who Code Boston to see if anybody who would want to attend with you. And so some tips for coming up with a hackathon project idea. Again, these are some of the things I consistently see within submissions, is that first-time hackers tend to overthink their ideas and kind of are a little bit too ambitious. I would just say keep it simple and plan out as much as you can before you start to code or design anything, because that 36 hours will go by super fast. And I don't want you to get to the end and not have something to show for your project because you decided you wanted to build like an entire OS in a weekend, and that's just not possible. Unless it is, you can prove me wrong. And then the second one is be clear about the problem you're trying to solve, especially if you want to win a prize, which is really important. The more specific you are with the problem you're trying to solve, the easier it's going to be to come up with a solution, the easier it's going to be to build out your solution. And again, the more likely you're going to win a prize or challenge. And the last part is like, have fun and challenge yourself. It's really easy to get caught up in hackathons and the stress of it. You like invest so much in your project. It's like your little baby for the weekend. But in the end, you're really just in there to have fun, meet new people, have the experience of building a product with other people, new people for the weekend. And again, so you're really just there to have fun and you challenge yourself. And that's what hackathons are all about. It's really just having fun and making cool shit. So again, workshops are a critical piece to hackathons. There's a huge range of hackathons. You can check out the schedules on hackathon websites before you register if that's something you care about. It can range from introductory workshops to advanced workshops. Again, always recommend checking out the schedule in advance, adding it to your calendar so that you don't forget. And again, you can just attend the hackathon just for the workshop, and there is nothing wrong with that. And again, I'm going to quickly go over this. There are some misconceptions on like how you might participate on a hackathon project. So again, for a lot of first-time hackers, they'll think, oh, I'm not good enough. I'm not, I'm trying to transition into backend, but I don't have any experience. I don't want to do that. But again, hackathons are all about learning and trying something new. That's the whole purpose. It's again like experiential learning. So again, I would recommend, taking on a role, even if you're unsure about it and trying it out. That's the fun of a hackathon. You get to like be on like what it might be like to take on that role in the real world just for the span of a weekend. So different roles in a hackathon are project presentation lead. So if you are an aspiring PM and you want to get the experience of scoping out a project, I'm not a PM, so I don't know like the specifics, but if you want to get the experience of scoping out a project, figuring out what features you need, what features are necessary, assigning different features to different coders, that is a role that is necessary to hackathon teams. You can do a design lead if you want to practice your mockups, you want to have something to add to your portfolio, front end, back end, and then backseat learner. So if you really don't want to participate and contribute, it's totally okay to join a team and say, hey, I'm not comfortable coding, or I don't have time to code this weekend, but I would really love to watch you build out the back end of this application. Would you be cool with, sharing your screen for the part when you, connect to the APIs, for example? That's, again, an option that a lot of people don't know about because they think they have to contribute to be a part of a team. And again, tips, if you want to get through the project, focus on time management and figure out which tasks you need to prioritize. Y'all are professionals, so you know about time management and prioritizations. And again, when you're submitting your project, again, no matter what state your project is in, no matter how much you contributed to the project, even if it's a prototype or just a sketch, submit it, because you never know how many people actually submitted to that challenge. It could be really weird and just your team ends up submitting to a challenge. So you never know if you're going to win. So it's better to always submit it than not. And this is the last slide. So again, as I said, networking at hackathons is such an incredible opportunity. It's a really good opportunity to connect with mentors, workshop leads, and organizers on LinkedIn. It's good for adding projects to your LinkedIn and resume. And you can also post about the project and experience on LinkedIn. And again, like really recommend connecting with people on LinkedIn because it's such an easy way to, connect with people who are in higher positions than you. Because again, they're at the hackathon, they know that people are going to add them. And so they're just going to kind of bulk accept them. Whereas, outside of the hackathon, it's a little bit harder to get their attention, to find an excuse for them to accept your request. So yeah, really good excuse to connect with people that you admire or may want to connect with later on in your career. So with that is what hackathons are. They are not malicious. And again, anyone can participate in them. So happy to answer some questions about hackathons and anything else related to the topic, but thank you.
So thank you so much, Fiona. I see a couple of questions in chat. The first one is, I only see hackathons for universities/colleges though. How prevalent are hackathons for post-college people?
Sorry, that was my question. I think Fiona answered that already. I just wasn't sure, but she did say that Tech Together is for everyone, right? Okay.
Yep. As long as you're 14 years and older, which I'm assuming you all are.
I know there's a pretty popular hackathon at MIT as well called, I think it's MIT Hacking Medicine, if I'm not mistaken. And that's a pretty popular one that doesn't just have college students.
Yeah. I think the industry specific hackathons are definitely, not collegiate focused. So if you're passionate about like healthcare or you're interested in like the healthcare space, I know that they run a lot of hackathons as well.
Cool. There's one question that's pretty time sensitive actually. Can we still attend Tech Together? As I'm assuming it's happening this weekend, if I remember correctly.
Yeah, our last hackathon of the season is this weekend. And yes, you can still register. And I can link you all right now real quick. And yeah, if you want to just hop on the Discord, see if you like it or not, attend some of the workshops for the weekend, you're totally welcome to attend.
Cool. And another question, how did you get involved with hackathons?
It's a great question. So it was really random. I, for some reason, got it in my head that I was going to go to Hack NYU. And I don't know why, but I showed up to NYU alone. This is when hackathons really weren't a thing yet. And yeah, I walked in and some guy was like hitting on me. It was really weird. And he was like, do you even code? And I was like, look at my laptop. Like these, I have girls who code stickers here. Like, of course I code. Why are you asking this? And so it was like a really uncomfortable experience, but I ended up having an amazing experience that weekend. Even though I didn't even build a project, and I realized this was the community for me. This is what I was kind of waiting for, of being around people that were just so creative and really just enjoyed making things with other people. And that's how I got involved with the Hackathon community.
Awesome. All right, well, thank you again for the talk. This actually brings me back to my college days, because I went to Brown and I used to be one of the organizers of our hackathon there as well, called Hack at Brown. And it was one of the fondest parts of, I think, my college experience. It was just so fun to, the whole weekend would be so exciting, just getting together with people who are also passionate about learning together. And I think that's kind of one of the things I love about being involved with Women Who Code. It's a group of people who just really want to learn together. And yeah, love the work that you're doing to get more women into hackathons. So yeah, thank you. Moving on to our last speaker of the night, Shruti Dalvi is here. Shruti is a software engineer at Smartsheet, and she is also one of our amazing leads on the Women Who Code Boston chapter. If you're looking to practice interviewing, you should definitely attend one of her events. She leads the algorithms and data structures events. It's a great opportunity to just brush up on your algorithm skills and yeah, meet other people. So yeah, Shruti, take it away.
Thank you, Indira. Hi. So like Indira said, I am one of the leads in the Women Who Code Boston chapter. Let me actually just set up my presentation and get that going. So today's topic, I am going to talk about brushing up some fundamentals. The last time we had algorithms and interview prep session, it was back in, I want to say August of last year. And then the whole COVID situation put a dent in what works and what doesn't work. And some personal things came up. Nonetheless, we're looking to get it started again. And I figured what better way than get to know each other this way. I am pretty sure we'll run out of time. So Indira, stop us anytime and then we'll figure out a good way to continue with the conversation. So a little bit about me. I worked at Microsoft for about 9 years. And before my current gig at Smartsheet as a software engineer, I taught data structures and algorithms at a coding school for women and gender diverse folks folk in Seattle called Ada Developers Academy. It was one of the coding schools which is rare to have data structures and algorithms as part of the curriculum. So even though I left that gig, I love talking about what made me fall in love with computer science. So which is why I talk about data structures and algorithms. And it seems like not all of us get the privilege of attending schools where data structures and algorithms are taught. Plus, it's always such a long time since we have last brushed it up before the next interview that the practice always helps. So today, we'll start with binary and we'll see how far we get into memory. If you think of anything at all, not just about questions for the topic, but things that you would like to brush up on, feel free to send those also as messages, and I'll post that at the end as well. All right. So computing problems all started with counting problems. Back even in the ancient Egyptian times, we started with counting. The Egyptians had figured out a way to count to 10, and then they had powers of 10 that they were counting up to. Then the Maya numerals also included 0 in it, and so on. One of the things universally bringing us all together, despite our different languages that we spoke, was math and counting, specifically the natural numbers. So with the natural numbers came the portion of somehow it always just worked out that we all started counting using the decimal system or the base 10 system. With the base 10 system, the natural numbers or the common numbers we know about, these are the 10 distinct symbols that we are all way too familiar with. And we start counting. The important, interesting portion over here, of course, you're all familiar with this. The interesting portion is looking for the patterns. So we start with the first symbol we know of. We go all the way to the last symbol that's available. And once we reach the last symbol, we reset it back to the first symbol and move the next symbol to the left to the next possible symbol. So 0 turns to 1 as we reset to 0. And that continues on in the pattern that goes forward. The interesting takeaway is, as we know, algorithms are all formed by observing a pattern that comes one after the other. And once we notice a pattern in a familiar space, in this case, natural numbers that we use every day, we can apply that to new system and any other base numbers. For example, let's take hexadecimal numbers. So hexadecimal is a base 16 system. That means there are 16 possible symbols. Now, even if I didn't know anything about hexadecimal, I could start with looking at what's familiar, the decimal number system, and look at how the pattern goes through. It starts with the 10 possible numbers that it goes through. Then it resets to the first one while incrementing the one next to it on the left to the next possible symbol. And then we can do the same exact thing with hexadecimal. We have 16 possible symbols that it can go through. So we go from 0 to 9 only. After 9, there are 6 more possible options of A, B, C, D, E, F before we reset to 0. And then the 0 in the tens place, as we normally think of it because of decimal number system, the 0 to the left of F converts to 1. And then the pattern continues on. So once we figured out a pattern, we can actually come up with an algorithm to say, produce, let's say, we have 18 possible symbols. Can you go through and write down all of the numbers with it? And you can write pseudocode pretty much right now based on following that pattern. Now, we all know that when it comes to computers, we are really talking about zeros and ones, the binary number system. So let's take a look at binary. The difference between decimal versus binary, we looked at decimal, we looked at hexadecimal, and then we looked at binary, is we have fewer symbols that distinguish things. So in decimal number system, we started with 0. We went all the way to 9, 10 possible symbols that we went through, and then we reset it. Whereas in this case, we have only 2 possible symbols, 0 and 1. So we start with 0, it goes to 1, that's the limit. So we reset it back to 0, moving the next digit over, the binary digit over to 1. Then we add 1 to it, making it, it's really, although it says 1, 1, it's really 3. it reached the last possible symbol again. So reset this to 0, reset the next one to 0, and then the symbol to the left of it becomes 1. One of the interesting patterns to notice is the fewer the number of symbols, the more spaces we need to represent the same number. For instance, if we wanted to represent 10 in decimal number system, we need to say the symbol 1 followed by the symbol 0 together constitute what we understand as 10 in decimal number system. The same thing in hexadecimal, I just need one symbol A, and that's all that we need. Whereas with binary, because the number of variations possible are only 2, 0 or 1 for each space available, we need 4 possible spaces, 1, 0, 1, 0. So we need 4 distinct spaces to just represent a much smaller quantity numerically. Now, this gets to an interesting problem. The number of possible spaces we have, in this case, I'm representing 10 with 4 possible spaces, makes a difference on what I can count up to. The binary digits, also known as bits, the number of binary digits I can have makes a difference on how much I can count up to. If I had just one bit, I can have the variations of 0 or 1. So 2 possible variations that are possible. If I had 2 bits, I can start with 0, 0, and then I can come up with the variations of 0, 0, 0, 1, 1, 0, 1, 1, so which represent 0, 1, 2, 3 in decimal. So I have 4 possible distinctions. With 3 bits, I can have 8 possible distinctions, counting from 0 all the way to 7, and so on. So the pattern observed over here is when I have k number of bits, then I have 2 raised to the power k possible variations, starting with 0 all the way, I can count up to 2 raised to the power k minus 1. Moving on with the same portion, I'm not sure whether we'll have time for actually allowing you time to think, but following the same pattern, if I had 8 bits, then I would have 2 raised to the power 8 possible variation. I'm sure if I give you enough time, you can do the multiplication. It comes to 256. So now, if we were going about this and counting integer values, given 8 bits, I can count from 0 all the way to 255 with 256 possible variations, including 0. Then all these could be stored. That means I can store integer values in the range from 0 to 255. What if I wanted to save in my computer, not just integer values that are positive values starting from 0 all the way up, but I also want to save negative integers? Now, this is the time when we start thinking about conventions. I need something to tell me, is this a positive number or a negative number? So I'm going to say, let me just take one of those binary digits, and I'm going to use it to represent the sign. Is it a positive or a negative? So if I take one of the 8 bits to represent the sign of positive or negative, I have 7 bits remaining. So the 7 remaining bits get used to count from 0 to 2 raised to the power 7 possible values. So 0 to 127 in positive integer value, as well as now I'm using the negative number with the same variation. So 1 bit goes to 0 or 1 to tell me whether it's positive or negative. And I can have minus 1 all the way to minus 128. Again, 2 raised to the power 7 possible negative values, giving us a total range of minus 128 all the way to positive 127. Now, you can pretty much follow the same pattern. All I've changed is the number of bits. And you won't have to do the actual math, but if we wanted to look at the range, this would be a range of 2 raised to the power 15 in negative value to all the way to 2 raised to the power 15 minus 1 in positive value. One of the 16 bits gets used up for representing whether it's positive or negative. All right, moving on. So behind the scenes, using the powers of 2 table is how we figure out and compute each of how 27 gets stored onto your computer's hard drive, or 42 gets saved, or 116 gets saved. I should call out, I'm going through this really, really fast. If we were doing this in a data structures and algorithms class, there'll be pauses here where we will discuss and have a lot more conversation. But the interesting portions are coming up, and right now it's more for the interesting portions of what makes the computers work together. So figuring out an approach to convert a binary number that's saved on the machine to a decimal number that we as humans understand and can read makes a difference. On the previous slide, if I just represented the zeros and ones together and told you this is 127, that wouldn't have made much sense even to me as a programmer. I need to see 127. So in order to make sense of it, again, we start with the known space, the decimal number system. So right now I'm looking at 453 in the base 10, the decimal number system. And another way to think about 453 is 400 plus 50 plus 3. Or in other words, talking about it with the base 10 system. So in the powers of 10 system, it would be 4 times 100 plus 5 times 10 plus 3 times 1. Or in other words, going from right to left, 3 times 10 raised to the power 0 plus 5 times 10 raised to the power 1 plus 4 times 10 raised to the power 2. Now, if we follow the same pattern for a binary number like 1101, we would think of it as break it down with 1000 plus 100 plus 00 plus 1. And then starting from right to left again, it's 1 times, only instead of base 10, we are talking about base 2 number system. So 2 raised to the power 0 plus 0 times 2 raised to the power 1 plus 1 times 2 raised to the power 2 plus 1 times 2 raised to the power 3. So anything raised to the power 0 is 1. So 1 times 1 is 1 plus 0 times anything is 0. So plus 0 plus 2 raised to the power 2. So 2 times 2 is 4 times 1 is 4 plus 2 times 2 times 2 is 8 times 1 is 8. 1 plus 4 plus 8 is 13, and hence 1101 in binary is equivalent of 13 in decimal. Now, why are we looking at this? Well, before we get to that, I should call out. Everything is based in 2 raised to the powers and details of it. Anything raised to the power 0 is 1 is an important thing to remember. I had forgotten that, and I had to brush up my fundamentals to remember that again. One of the interesting things that ends up coming up during interviews is these fundamentals, not so much knowing exact facts, but understanding the patterns comes in handy. If someone gives you a sequence of number in binary and asks you to compute the decimal equivalent of it, you have to pretty much spend more time coming up with this algorithm, and the actual program you write may not take that long. But it's really, can you figure out a pattern that always works and apply it and see if there are any exceptions for which you need to add exceptions. Okay, so with that in mind, I'm going to skim through this. There are more examples on how can you come up from a binary to a decimal number system. And as I said, one of the questions I was asked straight out of college was given a sequence of bits converted to decimal, and the number of bits is told to you ahead of time. All right, moving on. Now, many times it's not just integers, positive or negative, that we want to save in our system. We have files, we have poetry saved up. So that means in addition to thinking about numeric data, we want to save A as we understand it, or B. And how do we do that? And those are the portions where, just like we used some kind of a convention for, I will take one binary digit and use it for positive or negative sign, we have to come up with additional conventions. And that's pretty much what encoding is all about. It all started with the ASCII encoding system, where 8 bits were used with variations of it to represent different numeric values. But then over time, 8 bits were just not enough. They didn't allow for enough room for growth. So Unicode character sets came up. I'm going to brush through this, not going to go through details. But the Unicode character sets had several benefits. One, it was a global standard. It allowed for representing different symbols, punctuations, different languages across the world. So for instance, with all of that, something like Ada could have been represented as 011000001. Now, if I just look at the binary data and I don't know exactly what type of data is getting saved, I could easily read this as integer values and read them as 9797. So what type of data is getting saved where helps us understand what gets retrieved and whether you retrieve the right thing. So it's equally important to know what data you're saving in addition to what type of data it is. All right. Now that we have just taken it for granted and gone through some of the binary principles, why zeros and ones? Why couldn't we just stick to decimal number system? After all, we were all familiar with it. Why learn zeros and ones? And then one, to begin with, a bit is a binary digit, which is either 0 or 1. It finally comes down to everything. The silicon industry is called silicon industry because it's all electronic circuitry. It's all based in silicon. That's how it all began, with transistors saving our information. Now, when it comes to saving our information, and it's really the voltage levels that determines whether it's a high voltage level, and hence we save it as 1, or a low voltage level, and hence we save it as 0. One could argue, I have my light over here, it goes through different light ranges, I can dim it, I can increase it. Why not have 10 distinct voltage levels? Well, we could have, but only when it comes to our data. We don't want that to get messed up. Imagine our banking system getting something wrong with the amount of balance I have in the bank. We can't afford data losses or misrepresentation of voltage values when it comes to our data. So getting accuracy correctly. The same portion of the binary number system also got used at the initial uses of it were for communication during wartime. Is the enemy near or is the enemy not near is a very, very important answer. Getting that wrong could change the course of our future life. So as a result, when it comes to electronic circuitries, we don't want to take chances. We stick to 0 or off or low voltage value to represent false or 0, or 1 or on or high voltage value to represent true or logic 1. In fact, it's not just our data that gets saved up as zeros and ones, but it's also our programs, the algorithm that gets read, and finally when we're executing it, it's going through an electronic circuitry. So you'll notice, for instance, that these are known as logic gates, but really what it's doing, let me skim through this. I want to look at the diagram on this page. So what's interesting over here is it's representing any time, no matter which programming language you code in, you would have come across if condition A is true and condition B is true, then do something. If it is rainy and I'm hungry, I will have a hot cup of tea. In all of those conditional statements, and is like a fundamental programming concept, just as or not. So all of those are coming back to electronic circuitry. Now imagine the V portion at the top over here. I pass in a high voltage value in there. This voltage value goes in. A is where my first condition's result is saved. Is it rainy or not? And that is getting a true or false value. If the transistor, the resistor over here sends out a high voltage representing true, only then would this circuit be complete. Imagine equivalent of the light bulb over here lights up, and then there will be an output going out of it, which is high voltage value. If, for instance, the A circuit is false and it doesn't send out any signal, or it's a low voltage, the circuit over here will not complete and it won't send out an output value at all. So depending on whether the first condition is met or not, decides whether does it matter whether B is true or not, gets decided for an AND condition right over here. In fact, that's why we call it short circuit. If the first condition is false, don't even bother computing the second condition, just short circuit it. We already know we are not going to even look at the value of whether I'm hungry. However, if it's a rainy day, then I am interested in whether I'm hungry's value being true or false coming from the B resistor over here. So there's a high voltage value that continues going down, and I'm hungry returns a high voltage value. Then the second transistor will also light up. Imagine a light bulb lighting up. And then finally, the output that we receive, the final output, if I save the value of it in a third value C, then the variable will get a high value or a low value. So as a result of this is why no matter which programming language we are coding in, if conditions and or not are fundamentals to programming. We will always have them no matter which programming language. They are pretty much baked into the system. All right. Okay, so bits, bytes, and memory. So now we started with a bit is pretty much a high voltage or a low voltage. We've spoken a little bit about how the programs all run together. And now let's talk about what is a bit, what is a byte, and how it constitutes the memory that we know of today. A binary digit is a value 0 or 1. The memory cell is saving the value, storing the logic value of 1 or 0 at each cell. And several cells together form what we make sense out of. A byte is 8 bits together is what we call a byte. That's just the standard. In fact, you may already know this, but I think the old days computer scientists had a sense of humor. If it's only 4 bits, it's called a nibble because it's not quite the complete byte that you're having half of a byte. So have a nibble 4 bits is a nibble, 8 bits is a byte. The computer storage or memory can be thought of as a large array of bits, one after another. It's just an array sequentially placed together. An address can be thought of as an index into this memory array. Or if you go to a storage location where my storage currently is in the Woburn storage, where I know if I go to locker number 253, that's exactly where my data is. So you can index into it and figure out whether the bit is 0 or 1 at each of those addresses. One word defines how many bits the computer can make sense of at once. So a word like we do in a normal natural language is something that we can make sense of. A by itself may not, well, in this case it does. B by itself may not make sense, A by itself may not make sense, and T by itself may not make sense, but putting it together as bat, now suddenly it's a word that our brains understand to mean something. So similarly, whenever we say word in computer sense, it is how many bits together a computer can make sense out of. Most times it means the address goes to a certain particular location, and at every address location, there is 1 byte. So byte addressable is the most common way of thinking through addresses. So addresses can be thought of as an index. The address shares a location of where our data actually is. A word defines how many bits the computers can make sense of at once, and memory is typically word addressable, meaning at each address we have 1 word. And then byte addressable is the most common one. That means at every location we have 1 byte. I'm going to skim over this.
Hey, Shruti. So really sorry to interrupt. Yeah, I just wanted to just do a time check. We are at 7:24, so perhaps if you could try to wrap this up.
Sure. Let me get towards the end. Okay. Thank you. Let me see if I can do this one. All right. So there's a lot more, as you can probably tell. I run out of time usually, and a lot of this, especially in the preferred way, where this is a two-way conversation, it takes a lot more time. So join our Slack channel if you're not already on it, the Women Who Code Boston Slack. Algorithms and Interview Prep channel is where we talk about algorithms and interview prep. We also have another channel called Programming Questions, where another lead, Grace, posts in questions regularly so we can keep up to date. Just like Indira shared in the beginning, we are open to suggestions. What kind of activities would help with your preparations and with your interview prep? We are all ears. Let's try to make it happen the right way for our community to work. I'll also be sending out a survey shortly to see what kind of contents we want to go through, how we should prepare. So send me a note anytime. Also, you can reach out to Indira, Shane, or any of the directors or leads so we can make it our own thing. Note, I should stop sharing.
Thank you so much, Shruti. I see a question in the chat. Are there any books you can recommend for learning data structures and algorithms?
Now that's a tough one. It all depends on where you are at. If you are very, very new, I would recommend Grokking Algorithms is a easily accessible book. There are a few others that go into much more in-depth details. I have personally found some of the online resources to be much more helpful. I'll post them on the Algorithms and Interview Prep channel later on today with the resources link.
Yeah, definitely keep on, if you are on Meetup, which I'm assuming everyone is, because otherwise how would you hear about this event? But yeah, if you're on Meetup, you should definitely look out for our next algorithms event. Keep your eyes peeled. And of course, we have a lot of other types of events as well that will hopefully be of interest to you. Cool. Let's see. Any other questions? Yeah, we posted the link to join the Slack channel and Zoom chat as well. Please join. We want to make the community as lively as possible. Yeah, once you're there, introduce yourself to the group, join our various Slack channels. And yeah, I guess if there's no more questions, then thank you again to all the speakers tonight. Hope you all had a great time and hope to looking forward to see you all at our next event as well. Thank you, everyone. Have a good night.
Thank you. Bye.
Thanks for having me. Bye.